Salam sejahtera to Dr. Nur Farizan binti Munajat who will present our presentation titled Aurora Borealis explained by electromagnetic theory. Our group member consists of Muhammad Ilyasak bin Amir Abdul Hakim Al-Amin, matrix number S64662, Muhammad Ridwan bin Manguna, matrix number S64287, Nur Faradira binti Stefanius, S64732, Harlin Nurin, matrix number S64700.
What is the aurora? Aurora is named for the Roman goddess of dawn. The aurora is a mysterious and unpredictable display of lights in the night sky. The aurora borealis and aurora australis, often called the northern lights and southern lights, are common occurrence at high northern and southern latitudes. Less frequent at mid-latitudes and seldom seen near the equator. While usually it's a milky greenish color, auroras also can show red, blue, violet, pink, and white. This color appear in a variety of continuously changing shades. Sometimes, aurora is also dim and scattered as to be mistaken for clouds or the Milky Way. Sometimes, it is bright enough to read by. Aurora are spectacular signs that our planet is electrically connected to the sun. The light shows are provoked by energy from the sun and fueled by electrically charged particles trapped in the Earth's magnetic field. While beautiful to behold, they can be a nuisance to those who depend on modern technology.
So now I'm going to explain what makes aurora happen. So this activity that creates aurora begin on the sun. The sun sends us more than heat and light. It sends lots of energy and small particles. The protective magnetic field around Earth shields us from most of the energy and particles. But the sun doesn't send the same amount of energy all the time. There is a constant streaming solar wind and there are also solar storms. During one kind of solar storm, called a coronal mass ejection, the sun bursts out a huge bubble of electric field gas that can travel through the space at high speed. There, the particles interact with gases in our atmosphere, resulting in a beautiful display of light in the sky.
Now I will present about when aurora borealis happen. Aurora are visible almost every night near Arctic and Antarctic Circle, which is about 66.5 degrees north and south of the equator. To the north, it is called the aurora borealis or the northern lights, and the south is called the aurora australis aurora or southern lamp. The most active auroras happen when the solar wind is the strongest. Solar winds are usually good, although heating and cooling part of the sun can change regularly due to solar weather. Solar weather is often measured in sunspots, solar flares, and coronal mass injections are related with sunspots. Sunspots are the sun's coolest region, appearing as black blobs on the white hot surface. Sunspots are related with solar flares and coronal mass injection, and its energy bursts in the solar wind and occur suddenly. The activity of sunspot is monitored during an 11-year cycle. During the peak of sunspot activity, bright persistent aurora are most appearance. Every equinox, the solar wind becomes more active, known as magnetic storm. Magnetic storm can lead to aurora being seen in the mid-latitude during the time around the spring and autumnal equinox.
I will present my part what causes aurora. The aurora can be in unreasonable light, so that across when gases such as nitrogen and oxygen collide with charged particles from the sun that into the Earth's atmosphere. The best places to enjoy this beautiful view include northern Canada, Alaska, Finland, Sweden, and Norway in other areas. The aurora more visible during the winter because the light pollution is usually lower than the summer. The sun that sustains life in Earth is the center of the solar system, and as it rotates on its axis, its magnetic field rotates and destroys. Once the magnetic field are combined together, they tend to rupture and produce the sunspot. The solar wind sends charged solar particles across space. If our planet is on its path, the magnetic field interacts with the Earth's atmosphere. When these particles collide with molecules and atoms present in Earth's atmosphere, it stimulates these atoms which light up, emitting a dramatic colored display called an aurora. The color associated with this phenomena include white, purple, blue, yellow, green, and pink. When the ionized particles collide with nitrogen, they produce blue, purple, red color. As well as interaction with oxygen result in producing green, yellow, and blue color. The type of collision also determines the type of color produced. Atomic nitrogen display white collision with molecular nitrogen produce a pink color. The exhibitions also influenced by altitude. Purple and violet appear about 60 miles high. Blue is displayed at 60 miles. Green light about 150 miles high, while red displays are expressed over 150 miles and above.
Next, it can affect satellite drags. When invisible current of the aurora hit the air of the upper atmosphere, it affects satellites. Satellites orbit around the world and send millions of bits of data down to Earth, including report of an aircraft position to air traffic control. News reports indicate that if their solar flare satellites tend to hit a speed bump drag or get thrown off course. Sometimes this is more than just a few seconds of delay. If the satellite gets low enough altitude, it will eventually fall back to Earth.
Next, the effect of the aurora borealis is absorb the radio transmission. There are many planes rely on GPS and also may use VOR, known as very high frequency omnidirectional range. By receiving the radio signal, VOR detect the position of the aircraft and aids in staying on track. Cargo ship also use radio wave with VHF radio communication system to communicate with each other. Magnetic storm and active aurora can sometimes interface with communication. Radio, radar, and signal might be disturbed. Even communication satellites can be disturbed by reserve magnetic storm as radio wave interact with electron affected by interference. The high frequency radio signal can be become degraded or completely absorbed.
GPS malfunctions. Of course, satellites also run GPS. Modern ships of all types use the EXDIS, electric chart display and information system, which syncs with the GPS that help conduct their course. Airplanes use GPS as well to navigate the sky. When there's a large geomagnetic storm, which can crash auroras far and wide, it can cause issues with GPS, especially close to the equator.
In conclusion, aurora is mysterious and unpredictable display of light in the night sky and can be shown red, blue, violet, pink and white and more by following the causes such as season change, association with nitrogen, oxygen and ionized, rotator of sun on axis, Halloween and exhibition. A mystery for centuries, until about 100 years ago, we have taken this light for a god or a supernatural being land, sea and sky. The aurora happened because by the sun. Despite the beauty of the aurora is actually has a negative effect such as GPS malfunctions, satellite drag, and absurd radio transmissions.
That's all from us. Thank you.